I keep seeing people suggesting that in order to colonize Mars or terraform it, we would need to put Mars's magnetic field back.
Without having something to protect the planet from all of the solar wind coming from the sun, unfortunately Mars can never be habitable, even if we
thing you'd need to do to terraform Mars is to give it a magnetic field. Otherwise, any new atmosphere will just drift off into space again.
I looked into this, though, and it doesn't actually seem to be true. I'm going to explain why. Let's start at the beginning. 4 billion years ago, Mars had liquid water. It had rain clouds, it had a thick atmosphere. It was much more Earth-like, and would then have been presumably fairly easy to colonize. What Mars didn't have, or rather what it lost fairly quickly, was a magnetic field. Without a magnetic field, Mars's atmosphere was basically doomed from the start. I've made a quick simulation here. It shows a small section of Mars' surface all the way up to space and shows the atmosphere gradually boiling away. The solar wind, the sun releases lots of fast radiation, lots of fast particles, and these hit the top of the atmosphere and strip it away, gradually eat away at the atmosphere. Then as you lose the atmosphere, the world cools down. The atmosphere keeps the ground warm enough for water to evaporate, so once the air starts being lost, the pressure starts decreasing, the temperature starts decreasing, the amount of water vapor starts going down, and then so you go from a rainy climate to a snowy climate, and then eventually all of your atmosphere is lost and it's freezing cold and all the water is frozen. It's not necessarily lost from the planet, because once it's frozen, it's kind of locked into the ground. The radiation story is that this radiation coming from the sun and elsewhere in the galaxy can't be diverted by a magnetic field, because there isn't one. There's not very much air left anymore, so it hits the ground, and if somebody was there, the astronauts would be exposed to radiation. So this is correct. There's nothing so far that's wrong. The magnetic field would have stopped radiation, and it would have kept the atmosphere in place. But there is a problem. These facts don't quite add up to the story that the magnetic field needs to be put back. There are two halves. First, the radiation, and secondly, I'll talk about the atmosphere. And so radiation is fast-moving particles, mainly protons. I've got a diagram here. I've sorted the radiation from left to right, from the slowest to the fastest. So on the left, I've got the slow radiation, so these are the protons coming from the sun. And then as we move to the right, we get faster and faster. Some of these, up to about the middle, come still from the sun. And then past that, we've got they're called galactic cosmic rays. And they're much faster particles that can actually get through the Martian atmosphere. So the magnetic field changes this by, it rotates a particle, and the particles get deflected. They get pushed away from Mars, back into space. If I click here, I can turn the magnetic field on here, and you can see them moving. But one thing to notice is, if I put it at 1%, the particles are deflected, but only really the ones going slow enough that the atmosphere would stop them anyway. It does a 1% magnetic field, 1% of Earth's magnetic field, does not actually do anything for the problem radiation. The cosmic rays and the faster solar wind radiation still hits the ground. Deflected a little bit, yes, but it's still there. So the problem is, if you want to stop radiation, you don't just need a slight magnetic field. You need something as big as Earth's magnetic field, or at least as a fair chunk of Earth's magnetic field. Earth's magnetic field is not a normal size magnetic field. It's enormous. It's about 100 times bigger than Mercury, but it's certainly not technologically attainable in any realistic setting. And, making a small magnetic field will not help a little bit. It'll only deflect the radiation we don't really care about anyway. So the other problem is, the radiation on Mars is probably overstated. The overall impact of the radiation is as follows. Somebody standing on the surface of Mars for 1 year would have around 1 or 2% extra chance of getting cancer. Obviously that is high, but you've got to ask yourself, would an astronaut really be outside, out of shelter for the whole year? They presumably go inside, they're going to sleep in a cave or a tunnel or some kind of heavily shielded spacecraft. They would have needed a heavily shielded spacecraft just to get to Mars in the first place. They're going to be able to shelter. You would assume they're sleeping inside, they're doing all sorts of getting ready, they're brushing their teeth inside. So, the radiation isn't going to be that bad. You might wonder, well, how are they going to grow crops? The crops have to be exposed to the sun, and so they're going to be perhaps going to be in some kind of greenhouse. It is true that a greenhouse, and a spacesuit for that matter, a greenhouse will not stop the radiation that can already get through the atmosphere. But plants are really tolerant of radiation. You don't need to worry about your wheat dying off until the radiation levels are like 100,000 times stronger than they currently are. So I just don't think the radiation is that big a problem. As long as the astronauts are vaguely sensible, and that they're going to be, like, not fine necessarily, but it's not going to stop the whole colonizing Mars just because of that 1/3% chance per year. The other thing is, if we're going kind of more science fiction, a bit less realistic, and we're going to try and increase the atmosphere on Mars, that would already block the radiation. That would also solve the problem. So if you're going to add an atmosphere, you don't need to care about the magnetic field anyway. But that takes us to the next question. If we're going to put an atmosphere back on Mars, shouldn't we worry that we will put it back and then the solar radiation will just sweep it away? The answer is no. So I've made an animation here of the magnetic field protecting Mars's atmosphere. So at first I've got this simulation here of that you can see the plasma streaming in from the left, and it hits Mars, and you can see it's deflected, but it's deflected by hitting the atmosphere. This is what carries the atmosphere away. Now I'm going to switch on the magnetic field, and you can see immediately that there's now a shockwave forming, and there's a kind of tame area, there's a quiet area behind that shock, which means that less radiation hits Mars, and so the atmosphere is protected. That's how it works. But the question is, how long does this take? You might be assuming from what Sabine and Anton said that this is like 10 years, 100 years, 1,000 years. But it's not. The original loss of of Mars's atmosphere was like hundreds of millions of years, maybe even billions of years. And that was with a much younger, angrier sun. The sun, 4 billion years ago, was spinning a lot faster, and that generates a much stronger magnetic field, and that in turn means much faster, much more solar wind. And it was really that early anger, the young, angry sun, which caused Mars to have this kind of atmosphere loss. Nowadays, the problem has basically just gone away. In 2014, a space probe called MAVEN arrived at Mars with the intention of looking to see how much mass Mars's atmosphere was losing at the moment. And what it found is that it does vary a lot depending on the conditions of the solar wind, but on average it seems to be about 1 kilogram per second. Now, this isn't very much. This is the same as losing 1 Earth atmosphere every 100 billion years. So we're not talking about thousands of years, we're not talking about even millions of years. This is a very, very slow process. So yeah, the story is the magnetic field is really just not that important. It would help with the radiation if you could get a massive magnetic field, but we're not going to. The radiation just isn't all that bad anyway. From an atmosphere point of view, it's just this is just a dead end. Mars is not losing any atmosphere at the moment on any appreciable timescale. So yeah, magnetic field, not important.